All right, so in this video, we're going to be looking at a problem involving the definition of a limit. We've been given the value of epsilon, and we want to use that information to find the required value of delta. So to summarize exactly what's happening, we are given that this statement is true, that the fourth root of 16 is equal to 2. We know that to be the case, so the limit as x goes to 16 of this function is 2. And we are given how close we are in y to that value. So we have a y value, a function value, that is within 0.05 of that function value. Again, this is in the y direction. And what we want to determine is how close do we need to be in x? So how far away is delta? How big, how far can we be from 16 in order to satisfy this statement on both sides? Now, we don't have to go through the formal definition in quite the same way that we do when we have abstract x, abstract delta, and abstract epsilon both. We still do have to find a relationship between the two of them, but we'll have a specific value of epsilon to work with. And so that will make the math a little bit easier and, again, less abstract. Because this is a nonlinear equation, we'll actually get two different possible values for delta, and we'll have to choose the smaller one because we want to be close enough so that we can satisfy the requirement on either side. All right, so basically we're going to start out with solving our inequality for x. So this inequality means that either the fourth root of x minus 2 is less than 0.05, or that the fourth root of x minus 2 is greater than negative 0.05. So those are the two inequalities that we have to satisfy. So we're going to solve the first one. So I'm going to move the 2 over to the other side. So that's going to get me the fourth root of x is less than 2.05. And then to get rid of the power, the root, and to get x by itself, we're going to raise both sides to the fourth power. So x is going to be 2.05 to the fourth, which, we throw this in our calculator, is going to be 17.661000625. This is an exact answer, so I'm going to leave it that way for now. And then we'll round later. Usually these problems have some kind of rounding requirement at the end, because if you have a weird value, or depending on the kind of function you have, you might end up with, like if this was a third or something, you might end up with repeating decimals or something, and we don't really need 8 decimals. Now the second one, we're going to solve exactly the same way. So we're going to take the 2 over to the other side. So that's going to give us the fourth root of x is greater than basically 1.95, right? Because we add 2 to that. And then we raise everything to the fourth power. So x is 1.95 to the fourth. And we throw that in our fancy calculator, and we get 14.459000625. Now, to find the value of delta, we are going to have to calculate the difference between 16 and these values. So the absolute value of 17.661000625 minus 16 is going to be 1.66100, no, 2 zeros, 625. And then in the other case, 14.459000625 minus 16. That was a 14, not a 15. And this one I'm going to have a harder time doing in my head. So 1.54099,375. The smaller of these two values is this bottom one. And so delta will need to be less than or equal to 1.54099,375. Strictly less than if we want epsilon to be less than as well. So that is the solution to the problem. Again, it's basically solving an absolute value inequality and then figuring out how far away those bounds are. And they'll be uneven because the function is nonlinear, and you just shrink the bounds on either side to ensure that both ends are inside. So you choose the smaller value of delta. And so this would be our answer for this problem.